Let's do an example. Suppose we have y equals 2 times the absolute value of 1/3 of x plus 2 minus 1. Wow. Okay. First, there is a coefficient on the x, so let's factor that out. So y equals 2 times the absolute value. Now, within my function, which is the absolute value of x is my parent function, so within this absolute value, I'm going to factor out 1/3. So I have 1/3 times x, and 1/3 times 6 is 2 minus 1. Alright, so I'm going to make a list of my transformations, and I'm going to separate it into x and y so that it's going to be easier for me to graph. So first of all, this 2, that is on the outside of my function, so it belongs to y, and so that's going to be a vertical stretch by 2. This 1/3 belongs to x. It's on the inside of my absolute value bars. X is backwards, so instead of squashing this like it looks like it should, this is a stretch as well by 3. Then the 6 is also belonging to x, and it says go that way 6. This minus 1 is on the outside, so it belongs to y, so I'm going to go down 1. Okay, let's do this. First, I am going to sketch the parent function, which is y equals x. You can't see what I'm drawing. Maybe I should move my thingy. Okay, my extremely official graph. And here we've got some absolute value of x points, sort of like Shwajam. Okay, I'm going to switch colors so that we can see my original function and my transformation. I'm going to start with my very favorite point, which is 0, 0. It doesn't matter whether I start with my x coordinates or my y coordinates, as long as I do the stretch or compression and then the shift. So let's see. For giggles, I'll do the y coordinate first. I'm at 0, 0. My y coordinate 0 times 2 is still 0, and then down 1. My x coordinate's still at 0 times 3 is 0, and then back 6. So I'm at 1, 2, 3, 4, 5, 6, negative 6, negative 1. Right, now I've got the point 1, 1. Why don't I do the x's first? It doesn't matter as long as I stretch and then shift. So 1 times 3 is 3, and then back 6 has me at negative 3. Okay. My y coordinate is 1 times 2 is 2, and then down 1 is back at 1. 2, 2. Let's do y. Why not, right? Times 2 puts me at 4, but then down 1, I'm at a y coordinate of 3. My x coordinate's 2 times 3 is 6, back 6 is 0. Okay, now let's look at some negative x values. Let's see, negative 1 times 3 puts me at negative 3, and then back 6 puts me at negative 9. Oh my gosh, 3, 4, 5, 6, 7, 8, 9. Okay, my y value is 1 times 2 is 2, minus 1 is back at 1. I think I'm going to wimp out and not translate this point because it would put me way the heck over there and I don't feel like graphing it, so I'm just going to go like, whee. Okay, so points on this graph. Well, it's not exactly a vertex, but the tippy point is at negative 6, negative 1. And another point on this graph is negative 3, 1. Well, let's just kind of test this mentally. Let's plug in these x's and see if we get out that y value. So negative 6. I'm going to plug into my original function, negative 6. 1/3 of negative 6 is negative 2. Plus 2 is 0. The absolute value of 0 is 0 times 2 is still 0. Take away 1 is negative 1. So indeed, when I plug in negative 6, I should get out negative 1. Excellent. Let's try negative 3. 1/3 of negative 3 is negative 1. Negative 1 plus 2 is 1. The absolute value of 1 is still 1. 1 times 2 is 2. 2 take away 1 is 1. When I plug in negative 3, I should get out 1, and I did. Okay? So this is the correct function, the correct graph of my lovely function. And that's how you do it. Just remember, first factor out the coefficient of x, and then divvy up your transformations into transformations that affect the x values and transformations that affect the y values. And always do your stretch or shrink before you do your translation, your shift. As long as you do it in that order, it doesn't matter whether you do your x transformations first or your y transformations first. Now that you know the magic secret, I have 3 graphs for you to translate. So the first graph is, you've already done this, but just for giggles, I have a vertical stretch and a vertical translation. The second graph, I have a horizontal stretch and a horizontal translation. And the third graph combines the translations of the first 2 graphs into one glorious mess, which you will hopefully successfully graph. What I would like you to do is the same process I just did for all 3 of these. Remember, you only factor out the coefficient of the x. Don't worry about the y. And graph these in your spiral notebook, and then please go to either Desmos.com or your handy graphing calculator and check that your graph matches what your calculator thinks you should have.